Hello everyone, my name is Jacob Ozanich and I'll be showcasing my final presentation today in this video. It will encapsulate the hybrid model SDLC project that we worked on and the NRI 2.0 proposal. So go ahead and get this started. So first we do have that hybrid model research. Uh, it was a 6-page assignment where we looked at previously already established SDLC models, and we took all the pros from the models we selected, eliminated as many cons as possible, and then we formed our own hybrid SDLC model out of that. And then the other half of this presentation is going to be based on the NRI 2.0 proposal. So this was something that was given, is put out publicly, and our Capstone class was given the assignment of creating a proposal to submit on behalf of YSU. So first, we'll go ahead and get started on the hybrid model portion of the presentation. So for the hybrid model, there are 5 models that I selected for mine. It is the spiral model, the agile model, the waterfall model, the V model, and the incremental model. All of these are the ones that I dissected and used for my hybrid model. So uh, essentially, I'll have all the pros later in the presentation. I'll specifically hit on the pros I used, and we'll get to that later when I start talking about my hybrid model that I created from these. So first, we'll start out with the spiral model. It was first introduced by Barry Boehm in 1988 in a paper he wrote. There are 4 main phases to the spiral model. First, we have the planning phase. This is where requirements are studied and gathered with the goal to output a finalized list of requirements that can be understood and agreed to by both parties. Now, the parties in this situation would be whoever the customer is and whoever the vendor is, or the consultants or contractors are. Um, so when that phase is complete, both sides will say, hey, this is exactly what needs to be done. We agree that this is how it'll be done, and we agree that this is the overall plan for it. The next main phase is the risk phase. This is where brainstorming for possible risks that can happen during the process occur. So what this does is this helps clean up the process. It helps avoid any kind of problems that could be ran into, especially if you have top tier risk analysis. They're able to really dissect everything and really plan ahead. That way, the process runs into as few problems as possible. Third, we have the engineering and execution phase. And during the engineering execution phase, this is where actual development of the software and testing occur. So when that occurs, you have your development, which is the coding, programmers come in, write everything out, and then we have the testing, which is also equally important. Now, the testing phase is something that could either go smoothly if everything is successful, and the process will continue on. Otherwise, you have to go back, you have to revisit whatever step the problem occurred in, and then you have to redo that step in order to get it fixed. And then lastly, we have the evaluation phase. This is where the customer evaluates the output given from the engineering and the execution section, and then they provide feedback to the company. And that feedback can either be A, this is good, this is acceptable, it meets our requirements, or B, it could be, hey, we need something different. We didn't quite, have this in mind. So at that point, then it's on the consulting firm or the vendors to go back and see if they can change anything in that set of software to actually meet the requirements that the customers are looking for. And here is a diagram for the spiral model. So as you can see, we do have the planning in the top left, which is the requirement analysis. Then we have the risk analysis where the prototyping and designing are. And then the bottom right is the engineering and execution. And then the bottom left is the customer evaluation. And one thing to keep in mind with the spiral model, and actually this is actually a big con of the spiral model, as that spiral gets wider, the cost of the project becomes far and far more increased. So if this spiral model kind of gets stuck in a loop, it can become very expensive very quickly. So that's something I had to keep in mind as I was going through the hybrid model process. I had to keep in mind that the spiral model has had scenarios before where they were never able to get out of it and ended up being very costly for everybody involved. Next, we have the agile model. Now, the Agile model, it became prominent in the early 2000s. However, there have been examples found where the thought process of Agile actually dates back further, at least to the 1970s, if not earlier. And the focus of Agile is that it focuses on rapid development. The code is built in very small segments, it's tested and it's implemented, and then it gets feedback very quickly. So the numerous occurrences of testing and integration, that's frequent. Every time a new set of code is made, they test it to see if they can integrate it. And then once they're past the testing and integration, it then reaches the customer for feedback, as we can see here in this graph. So first you have the start, which is where the project is initiated and the requirements are defined. And then as you can see, this graph shows 3 examples, but it could be more of integration and testing. And the clients do have almost near continuous visibility to the project because they're constantly getting updates basically through the agile model. And so when the integration testing occurs, assuming that if the testing goes well and it's successful, then it goes to the client for feedback. And then it's up to the client to then approve that set of code or to reject it, and then it has to go back through the cycle again, which you can see in the blue. So the approve, and then if it goes, and then if the client says no, they have to record and incorporate the changes and adjust for that into the future, and then go ahead and then they start the iteration again of the model. If it is approved, then it is deployed into the market. It'll be added as an update to the already existing software that was made from iterations beforehand, and then it just continues until completion. One big knock of the agile model is that there's very little documentation, just because they're constantly working on code. Nobody really takes the time to write out everything. They just keep hammering away at code, and then they go and get that feedback from the client, and then the cycle just keeps going and going. So they don't really have any kind of rigid documentation of the process as it's going on. Next, we have the waterfall model. It was first introduced by Winston Royce in 1970. One of the things that separates it from the other groups is that it has distinct step-by-step phases, and everything flows in logical order. So with the waterfall model, there are 5 main stages. First, the requirements analysis phase. This is where requirements are analyzed and written down for future use. And the waterfall does feature strict documentation. It is very rigid in its process, which can be a pro and a con. The next is the design phase. We have this is where the design gets created that outlines the business logic covered in the previous stage. So this is where the design of the software or the design of the project occurs based on the information gathered from the stage before. Thirdly, we have coding, which is where the source code is written and implemented. So in the third phase, this is where they actually build the software. This is where programmers will come in and get everything written, put together, and then that leads to the fourth phase, which is testing. And then testing is just the testing of code to make sure it's functional, or if they need to go back and revise something. And the fact that testing is so late in the cycle is one of the knocks against the waterfall model. So this process right here, this 5 steps could take 2 or 3 years. So if the testing is that delayed, by then requirements could have changed. The waterfall model doesn't really feature any kind of late stage adaptability. It does have adaptability early on during the requirements analysis and design phases, but as we get further down and the time period starts to get longer and longer, it isn't nearly as adaptable as it is in the beginning. So assuming that the testing phase is passed, we then go on to the maintenance phase. The maintenance phase is pretty self-explanatory. This is where the solution is deployed into the real world, and maintenance is supplied either through the vendor or through some other third-party company to keep it running, keep it functional. But again, the maintenance could be an issue if what they build is already out of date or already needed to be changed. The maintenance can be an issue because they're already behind. So the maintenance phase could be very helpful, or it could be something that they already need to design something else, so maintenance of that one isn't really required for a long period of time. After the waterfall model, we have the V model. The V model is a it's a derivative. It is derived from the waterfall model, and then the information is actually recycled within the V model process. This is something that is a perk to the V model because it does help fix the waterfall model slightly. So as you can see here, the V model is split up into two different sides, the verification phases and the validation phases. So first we have the requirements analysis and the user acceptance testing. A pro of the V model is that these the parallel sections almost work in a pair, whereas the information or design or anything produced from the left side of the V model can actually get recycled into the parallel pairing on the right side of the V model, which is a big plus. So first we have the requirements analysis and user acceptance testing. This is where, on the requirements analysis, this is where requirements are collected and analyzed. And then the pairing aspect of that is that it can be flipped and used for input for testing, the user acceptance testing, with the goal of verifying the end system meets the needs of the users. Then when we take a step down, we reach functional specifications and system testing. So the system design is created during the functional specification stage, and then the system testing derives from it. So the design that is made on the left side is then incorporated as the V model goes on, and the system testing works with that design, and it makes sure that the system it meets the expectations that are required. Then when we drop down again, we have high-level design and integration testing. So with high-level design, the high-level design consists of specifications being designed. Modules are being broken down into details such as brief descriptions, interface relationships, dependencies, databases, tables, diagrams, and details of the technology that are going into the system. And the integration testing takes everything that is explained in the high-level design, everything that's specified, and it tests to make sure all the models and everything about them are compatible with each other. So those two work together very well because it just recycles all the information that is gained from the high-level design and is incorporated into the integration testing. Then we have the detailed design and program specifications and unit testing. So during the detailed design phase, there's a detailed design of all the modules so that programmers can actually begin the coding. This phase produces pseudocode through detailed logic produced by the program specifications. Unit testing verifies that the small modules can operate correctly in an isolated environment. So the unit testing first makes sure that each module can function fully on its own before it's implemented into the system. This is a very good fail-safe plan because the unit testing can catch bugs early on before you get further up the right side of the V and you start running into issues. So the unit testing can make sure everything works on its own before it's implemented within the group. And then at the bottom, you have coding, and the coding is fairly self-explanatory. This is where the programmers actually write the code, and then they check it multiple times. They check it by testing it. Excuse me. They test it, and they make sure that it's functional and that it works, and that it helps eliminate any bugs that could be in the coding. Oops, sorry about that. And then we have the incremental model. So the incremental model, in its history, it was hinted at a lot, but it wasn't until later that it was specifically mentioned. So first we have Walter Schubert. He did this in the 1930s. He was a quality expert for Bell Labs and proposed what's called a PDSA, a Plan, Do, Study, Act cycle to help improve quality. That same PDSA cycle was echoed again by W. Edwards Deming in 1940. The first specific mention was made in a report in 1968 by Brian Randell and F.W. Zurcher, and they were quoted as saying, "The basic approach recognizes the futility of separating design, evaluation, and documentation processes in software system design. The design process is structured by an expanding model, seeded by a formal definition of the system, which provides a first executable functional model. It is tested and further expanded through a sequence of models that develop increasing amount of function and an increasing amount of detail as to how they function is to be executed. Ultimately, the model becomes a system. So to break that down in layman's terms, I will use this graph on the next page. So as you can see, we have the requirements on the left side. Those requirements are then broken down into smaller, more manageable modules. So first we break down the first section, which is build one. It'll go through design and development. It'll go through testing, and then if it does pass through testing, it'll go to implementation. And then we go into build two. Same process, design and development, testing and implementation. And then that design just keeps going so that the modules are more manageable, they can be executed, and every time they're implemented, it just builds onto the previous software. So this this process works really well as far as breaking things down, and it makes them easier to manage as the process goes on. So with all that being said, the pros that I looked at specifically for my hybrid model, I do like the framework of the incremental model as far as getting all the requirements and then breaking it down into smaller, more manageable sections. I do like the risk analysis from the spiral model. I feel like a risk analysis phase is important because it'll help eliminate possible problems in the future. And then for the pro of the clear and complete definition and design, that's from the waterfall model. I personally believe that if everything can be extremely clear and complete up front, it'll avoid confusion later, and also it could help reduce the possibility of being stuck in a loop through the hybrid model. So the next one is milestone/completion dates. That comes from both the waterfall model and the V model. Both of those models contain this feature. So I picked those because I feel like having some sort of goal date or a target date to work for helps improve productivity. So by having those in place, it'll help those working on the project to stay focused. It can also reach, and those milestones can also be small victories, which can help keep morale high for the team, which can help further processing go smoother. So those milestones and completion dates will be implemented. I like the frequent testing and implementation of the agile model. As I said earlier, the waterfall model, one of the knocks against it is that it doesn't test until it's really late in the process. But I feel like with the agile model, or it happens in the incremental model as well, that if you test whatever software you're creating at that moment, like if you write a bit of code, you test it, make sure it functions, and then you go ahead and implement it. And then one of the last few things I picked was frequent communication. Having frequent communication with your client can be extremely beneficial. It'll help make sure that both sides are happy with how the process is going, and also it makes sure that they are able to provide feedback on the project. Feedback is important because the feedback can help make sure that once you get to the final build, you are certain that it'll meet the requirements or expectations that the client is looking for. So with that being said, and as I already kind of showed you earlier, this is my diagram for my model. So first we have the requirements. The requirements, like I said, they'll be clear and complete, like in the waterfall model. So the requirements in this is strict. It provides a lot of documentation that can be used for all the other phases throughout the JMO model. And then that knocks us next to design. And now this is where it starts to, this is where I'll have it break off and work into smaller functions, just like in the incremental model. So first you have the design of the project, and then you take a small section of that design, you run a risk analysis on it to help avoid any bugs in the future or any problems in the future. So you run the risk analysis, then you run the development of that smaller broken chunk. So that'll be where the coding takes place. That'll be where it's written. Then you test it, make sure it works, make sure it functions, and then you provide that to the client or customer. They can provide feedback on it, and then if the feedback goes well, it gets implemented, and then if it does get implemented, it just loops back up to the design. You'll design the next smaller part of the project, and the process will continue to repeat. I feel that this avoids a lot of the cons made by some of the, previous models, such as the waterfall model and the spiral model. So I feel this design here would be extremely beneficial to a lot of situations, and it'll be something that can be used by many teams and can be adaptable, because the requirements at the beginning does create such a strong defined documentation set that the rest of the project can flow right off those requirements and be good to go. So that completes my portion of the hybrid model section. We will now be stepping into the NRI 2.0 proposal. So first, I'd like to give an overview of the NRI 2.0 proposal posted. So the goal of the National Robotics Initiative, NRI, is to support fundamental research that will accelerate the development of and use of robots in the United States that work beside or cooperatively with people. The original NRI program focused on innovative robotics research that emphasized the realization of collaborative robots, or co-robots, working in symbiotic relationships with human partners. The NRI 2.0 program significantly extends this theme to focus on issues of scalability, how teams of multiple robots and multiple humans can interact and collaborate effectively, how robots can be designed to facilitate achievement of a variety of tasks in a variety of environments with minimal modification to the hardware and software, how robots can learn to perform more effectively and efficiently using large pools of information from the cloud, other robots, and other people, and how the design of the robot's hardware and software can facilitate large-scale, reliable operation. In addition, the program supports innovative approaches to establish and infuse robots into educational curricula, advance the robotics workforce through education pathways, and explore the social, behavioral, and economic implications of our future with ubiquitous collaborative robots. Collaboration between academic, industry, nonprofit, and other organizations is encouraged to establish better linkages between fundamental science and engineering and technology development, deployment, and use. Well-justified international collaborations that add significant value to the proposed research and education activities will also be considered. So there's a lot to digest there. So basically what they're looking to do is create ways for more facilities such as schools or workplaces that deal with robotics or AI. It's looking to find a way to facilitate that. So what she was planning to do is create a virtual lab. So basically, this would be a huge opportunity for YSU, and this could be something that could be very beneficial to the area and to the university as well. So for us to complete this proposal, we were broken up into different teams. I was a part of the first two teams, the database team and the web development team. So what the database had to handle was it had to track users, it had to track the resource availability, and that means the resources were the sensors, the robots, the environments, and we also had to track lab schedulings. Obviously, we can't have two people trying to run the same robot at the same time. And then we also had to track those requests. The lab scheduling and requests kind of go hand in hand. Then for the web development team, they had to present availability to those using the website, so they had to be able to see the calendar, see the scheduling, and the objects that are scheduled. And then again, scheduling, and we had to present the experiment environment. So we had to be able to showcase the two different aspects, which are the water tank and the terrestrial area. We had to provide video feed to the lab so that those working or those trying to do experiments from anywhere else other than in the local area are able to see how the process is going. And we have to provide communication with on-site staff. The security team had to handle a lot of different forms of access. Those forms are electronic, database, physical, equipment, software, and they had to provide protection of the website server. And then the project management team had to coordinate production. They had to coordinate the teams, make sure everything was completed on time. And then they also had to take care of the budget. And lastly, we have the social media team. They had to take care of any kind of comments made on the social media sites, announcements, any kind of posting of photos and videos, advertising for the lab, or support group collaborations. So as I said, I was a part of the database and web development team. So for the database, the main things we had to focus on were the users, those that registered through our website, and are the ones that submit any kind of code or experiments to be ran. We have the lab requests, and then we have the lab schedule. We have the robots, the sensor resources, the environment resource, and the employees. So as you can see here, this is a breakdown of our different tables. So under the users, we have the user ID, the username, password, their contact information, and their work or school affiliation, and the position they hold within their work or school environment. Then at the top, we have our lab schedule. This would incorporate the user ID from before so that we know who is requesting the time. Then we have the lab request ID, the time that they requested, and the date of the request. Then that breaks us down into the lab requests table, which is kind of the heart of our database. So we have the lab request ID, which binds to the lab schedule. We have the user ID to bind to the user. And then we have the lab request, the environment ID, which is either the water tank or the terrestrial area. And then we had to account for a lot of different attributes that can be held within the water tank. We had to monitor what they selected for the pH level, the robot type, the turbidity of the water tank, the lighting of the water tank, and any extra chemical content that they wanted to be included in the water tank. Additionally, we had to account for sensors. These sensors are all the different sensors that can be used on the robot during the experimentation. Then we had to use the robot ID, the employee ID, which is the employee that will be handling that lab request, and then the resource ID. So going to the top right, we have to also account for employee records. So we have, the employee ID, the name of that employee, their contact information, and other signature information such as their social security, to keep track of all the on-site employees that will be working for us. We have the sensor resources, which is again the sensors that will be attached to the robot. So we had to account for the name and a description of it. We also had the environment resource, which is similar to the sensors. So we had to account for the area, which would be water tank or terrestrial, and a description of it. The terrestrial did have multiple areas that they could use, so we had to account for that. And then at the bottom, we had to account for the robots they picked. There were different robot types, and we also had to account for a description of those robots. And then we have our social media info, which is the user ID of the user and their connecting accounts to either Facebook, Reddit, which made a subreddit for this presentation. I'll touch on that in the website section, or their YouTube account. So that is a breakdown of all our tables and the relationships of them. So next we will go on to the website. And for the NRI proposal, the web development team decided to use WordPress.com. We chose WordPress because A, it is a simple to use website. It allows users to make professional looking websites without putting a lot of confusing work into it, worrying about the HTML code or anything like that. And additionally, it is very adaptable. So say if the proposal gets accepted and YSU gets to start working on this, 10 years down the road, if nobody from the original crew on the web development team is still there, then with WordPress, whoever comes in can adapt to WordPress very quickly, and they can continue to operate it and maintain it. Whereas if they had to come in and try to dissect thousands of lines of HTML code, that could be very difficult. They could be used to different logic or different programming language completely in general. So WordPress operates as a good platform to function with. Then there are a few features of WordPress that we decided to include to help ensure that the site runs smoothly. So first we have the WordPress business plan, and in order to properly address all the requirements of the official website, we recommend the business plan. It'll cover all the basic needs of the website, as well as allow for the recommended plugins to be installed. This business plan is approximately $300 a year. However, it does provide some key features, including unlimited storage, unlimited premium themes, which can help with the cosmetic part of the website. In addition, we also can use Google Analytics, This is great because we can track, who's using the website, and we can also use advanced search engine optimization tools. So the search engine optimization is a key feature because that means that we can then improve where we place on Google whenever people search for it. They can search for virtual lab, they can search for YSU, but our site would have the search engine optimization, which means it would appear higher in the list. And then we go to the WordPress booking and calendar plugin. WordPress DevArt makes a plugin that will enable people to look at a calendar and see what days are available to run experiments with the robots. People can look at upcoming months to find the best days that work for them to run their tests. Not only will the plugin give them ability to look at the dates, but it'll also let them schedule what time on their chosen day to run their experiments. Paying for a business version of this plugin will give the whole booking calendar system many more features. For example, there are customizable designs, editable reservations, a minimum and maximum time and date option, and those are very key to the success. So the additional purchase is recommended, and these extra features with the scheduling system could help the website become a very, very important aspect of the whole NRI proposal aspect. Next, we have Video Whisper. Video Whisper will be what we use to implement the web feed, the video feed to those running the experiment. So Video Whisper allows for one-to-one live video conferencing that can be used to communicate with the staff that's on site running the experiments for those who are off-site. And also using this plugin, the researcher or those conducting the experiment will have access to the live feed of web cameras that will be positioned in different areas at the facility and project area for the experiment that they're running at that time. This plugin, Video Whisper, is web-based through WordPress, so there's no need to download anything or have any additional software installation for either the researcher or those working on the project at the lab, which is a big key because anytime there's any extra software that somebody has to download, it can lead to confusion, and that confusion can lead to no longer using our services. So by having a easy to use video communication tool, that can really improve the process for everybody as a whole and improve the experience. Next, we have Ninja Forms. Ninja Forms allows for the creation of an unlimited number of forms with access to an unlimited amount of fields available within each form. So this form will allow us for determining forced required fields as well, such as forcing them to insert a username and email, or whenever they're filing out the forms to request lab time. So this is key because we can make sure on our end we can require certain fields that we need every single time. We don't have to worry about leaving it completely up to the person requesting for the time where they could lack information, and then we have to take extra time to try and get that information from them. And then we have the Ultimate Member section of WordPress. The Ultimate Member feature is a large bonus to WordPress. It offers a good amount of features just within its standard package alone. Some of these features include user registration, user login, user profiles, member directories, user roles, content restriction, custom fields, and user emails. All of these will help tremendously out the gate, even in their standard free package form. There is a Ultimate Member plugin purchase availability though. They have a bundle that they offer that does include more features. Some of these features include private content, the ability to add friends, the ability to connect their Instagram or social media, check verified users, real-time notifications, user reviews, and MailChimp, and a social login. So a lot of those are key. The social login would allow people to log in through like their Facebook information, which could help, just the accessibility. It's quicker to just hit, log in through Facebook, and then the person is then implemented into their account. So that's a nice little feature, not really necessary, but it can be beneficial down the road. And then we have the security plugin. The security plugin is obviously used for security protection, and also has an auditing and monitoring system that keeps track of what is happening on the website. And some key features of this include detection, which scans every angle of the website to catch internal and external hacks. It does offer continuous monitoring, incident alerts, remote scanning, and a server-side scanner. These can be very vital to the success of the security of our website. In addition to that, it provides protection, which will instantly block hackers who try to take down the website. It features a website application firewall, a DDoS mitigation, a virtual patching and hardening of the security system, and it also provides prevent zero-day exploits. So it will overall really put our system on lockdown. It will provide a great way for us to keep all the information secured, especially since we're going to have a lot of information of those outside of Youngstown. We're going to have a lot of information of people from across the country, possibly, or even, who knows, maybe it could expand large enough to include other continents. So with that high level security, it can be very beneficial to us and the success of our website. And lastly, I have my contact information. I have provided all the information to my best detail that I have in this experiment. As of right now, we are unable to submit the proposal. The committee has not set a proposal date for us to be able to submit it. So as of right now, that is the best information I have to offer. However, down the road, if you'd like to inquire more information, or if you have any questions about my hybrid model or about the information I discussed in the NRI proposal, feel free to reach me at the email jmozanich@student.wshu.edu. Thank you.